Good morning, students. So, in the previous class, we discussed about the base drive control techniques for bipolar junction transistors. Okay, there are various types of base drive control methods we discussed: uh, on control, off control. Okay, then proportional base control and anti-saturation control. The problems on that those also we have solved in the previous session. Now, in this session, we'll discuss about the isolation of gate and base drive circuit. Okay, so there should be an isolation between the gate and base drive circuit in case of BJT or in case of MOSFET. Okay, that is, isolation means to separate the drive circuit from the main circuit, or to separate the base circuit from the main circuit. That is called as a isolation of the circuit. So isolation, why it is required, so we'll discuss it once again. So you may get there are few of the questions which they are asked in the previous year questions, that is, discuss the needs of methods of providing the isolations of gate and base drive circuits from the power circuits with the necessary circuit diagram. So it is asked in the various different manner. It is asked the same questions. So first we'll discuss why the isolation is needed. Okay, so isolation, why it is needed, because we have a gate circuit, we have a base circuit. So gate drive is provided to trigger the MOSFETs or trigger the IGBTs. Okay, so but there should be an isolation. So why, what is the need of, or is the necessity of isolations, so that we will discuss in this session. Okay, so the need of isolation we'll discuss now. Okay, so isolation is required. This you can see. So it is a BJT, base drive circuit. BJT you have. So this is a load and this resistance, and it is a triggering circuit. So isolation means what happens, so sometimes there is a fault occurs in this any input side. If any fault occurs, then fault current starts flowing. So if the fault current directly flows to your bipolar junction transistor, your transistor is burnout. So that is why there is a separation between the BJT and the power circuit. Okay, there should be a power circuit and the BJT, there is a separation. So that if there is a separation between the BJT and the power circuit, so if you are separating it like this, so then if anything is happens, if any fault current is comes, then your BJT will be isolated and it will protect the other part of the circuit. So you know that. Just yeah, just a minute. So we know that there is a driver circuits operates at a very low power levels. Driver circuit is nothing but your gate drive circuit or base drive circuit, whatever it is, so which is operates at the very lower value. Okay, then which their drive is connected to the power devices which operates at the higher levels. Okay, drive circuits at the lower power levels, and the base drive circuits at the higher power levels. Okay, this, so you can see the configuration of gate drive circuits, trigger circuit which is connected to the base terminal here. So in the figure, observe that the collector of bipolar junction transistors have a voltage of 200 volts, but the base is connected to the trigger circuit that is having a 5 volts. So are you understanding? Observe that the BJT has high voltage of 200 volts, but the base terminal is connected to the 5 volts. So base terminal is, so see here it's a voltage is 200 volts, but the base voltage is connected to 5 volts. So why it is connected? So if the BJT is damaged and the collector base gets short circuited, okay, then the high voltage will be connected to the circuit, and this will damage the trigger circuit also. Okay, if high voltage is connected to that particular point, so it will also, there is a chances, there is a reverse flow of current from load to the source will happens, then it the chances of burning of your input or a trigger circuit is also happens. So that is why, to avoid any damage to the triggering circuit, because you can see in this case, you see here is a 200 volts is applied here, 200 volts. Okay, collector and emitter voltage, but the base voltage is 5. So if anything is happens, there is a chances of reverse flow of current is takes place to the trigger circuit, so then there is a chances of damaging to the trigger circuit also. So to protect this, there is isolations is used, so that is called as the isolation of gate and base drive circuit. In case of bipolar junction transistor, it's a isolation of base drive. In case of MOSFET, it is a isolation of gate drives. Okay, so to avoid any damages to the trigger circuit, okay, there must be some electrical isolations to avoid the damage of electrical, to avoid the reverse flow of current. There must be an electrical isolation between them, so that is called as a isolation of gate and base drive circuit. There are two ways of isolating the control or a gate signals, okay, with respect to the ground. There are two different methods that are used to isolate the gate and base drive circuits. So first one is a pulse transformer and the second one is optocoupler. You can use the two methods. So two methods to isolate between the gate and base drive. So one is pulse transformer you can use, or you can use the optocouplers. So by using these two methods, by using these two techniques, you can isolate the gate from the base. Okay, that is the main. So first we'll discuss about what exactly the isolation of gate and base drive circuit using the pulse transformer. What is the pulse transformer? How the isolation is happens in this pulse transformer? You can just look at the figure. This is an indication or schematic representation of a isolation of the base from the pulse circuit, base from the logical circuit using the pulse transformer. So this is a schematic representation or equivalent diagram which will indicating the isolation which is provided to the bipolar junction transistors by using the pulse transformer here. Okay, this is the isolation. So pulse transformer have one primary winding and can have a one or more secondary windings. Pulse transformer, there is a one primary winding to supply the voltage. There may be secondary, it may be primary, it should be one, and secondary may be one or two, whatever it is based on the requirement. That's called as a pulse transformer. So this figure shows a transformer isolated gate and base drive circuit. As I said, this is indicating the isolation of gate drive circuit arrangement using the pulse transformer here. Okay, you see here the transformer should have a very small leakage inductance. Okay, so the rise time of this pulse transformer should be very small. So observe that in the figure 1. So triggering circuit electrically isolated from BJT, hence if there is any electric damage to the BJT, there will be no effect on the triggering circuit. So you can see here, so this is your logical circuit. So the signal from this logical circuit is passed on to the secondary transformer. So from that the base will be getting the current, required amount of the current. So if any fault occurs, if any high amount of leakage current, if it is reversely flowing, okay, so as there is a isolation is provided using this transformer, your leakage current is only comes up to here and it will stops here. So there is no leakage current flows through your logical circuit, so your trigger circuit will be protected from the faulty aspects, faulty conditions. Got it? So here what happens, the logical circuit is there. So pulse transformer, this pulse transformer is acts as the isolation here. So this pulse transformer, then BJT, then load. If any fault occurs in this particular load side, so large amount of current flows from collector to base. Okay, so in addition to protect the logic circuit, there is a pulse transformer is used here. So this pulse transformer, so there is a current will flows from here to here, and as there is a isolation pulse transformer, there is a reverse flow is not possible, so only you can transfer the power from here to here. So this pulse transformer will cut down the power supply between the base of the BJT and the logical circuit. So if the power supply is cut down, then the reverse current is nothing, there is no path for the flow of the current. So hence your logical circuit or the trigger circuit is gets protected. Okay, that is the method of isolating the BJT using the pulse transformer. The advantages of this type of isolation is the pulse transformer does not need any external power for its operation. Pulse transformer, there is no any external power is required for its operation in case of the pulse transformer, and it's very simple to use, just a transformer which will isolate when the faulty current which flows. Okay, so some of the disadvantages, if any there are any advantages in the circuit, then there are some of the disadvantages also. So if the disadvantages, if you're talking about the pulse transformer, saturation at the lower frequency. Okay, hence it is can be used only for the high frequency applications. So there are some low frequency applications we have, and also high frequency applications we have. So as the pulse transformer will be saturating at the lower frequencies, so we can use it for high frequency application instead of low frequency applications. Low frequency applications we can use the any other different methods to isolate them. Okay, so this is best suited for the high frequency applications. Due to the magnetic coupling, the signals are distorted. So there is a magnetic coupling between the magnetic coupling is nothing but your windings. So because of that, so there is a signal, maybe sometimes there is a distortion in the signals is also happens. So there are, if any system if you're having, there are some advantages. If there is advantages, then definitely there is some of the disadvantages also. So just we have to use some of the other techniques to mitigate the drawbacks of the system, and to use the systems in an effective manner. Okay, so that is the isolation of gate and base drive circuit using the pulse transformer. Okay, pulse transformer, I think you got it, pulse transformer. The second one is using isolation using the optocoupler. Optocoupler, this here in this representation equivalent circuit, it is by BJT is not indicated here, just isolation part we are indicating here. So you can say here we have a BJT circuit, then load circuit, whatever it is. Okay, here is a BJT, here is a load. Okay, so you can say BJT then load. So it is connected like this, like this. So in this isolation using optocoupler, this is the equivalent representation or schematic representation of a isolation of gate and base drive circuit using the optocoupler. Optocoupler is nothing but, as the name itself says, opto is nothing but it's a light related phenomenon. So optocoupler, which consisting of the pair of infrared LED and photo transistors. I think LED is nothing but diode. You have light emitting diode, so this is your light emitting diode. Okay, and it is a photo transistor. Photo transistor, what is the function of photo transistor? The function of photo transistor is, as the name itself says, photo is nothing but the electricity, I mean light. Okay, so this photo transistors is works only on the photo based on the light. Okay, so this is the input to the LED. It may be some 5 volts, 12 volts, whatever the based on the LED requirements. So that is applied to this light emitting diode. So once the LED receives the supply, so LED starts glowing. Okay, so the light emitted from this LED will be fall on the photo transistor. Okay, then your transistor starts acting. Okay, transistor starts acting. So if any fault occurs, then the supply to LED, if you turn off the supply to this LED. So if you turn off the supply to LED, the light emitting diode will not emit any radiations, so your BJT will not operates. So here also there is isolation happens. So that is the technique we are using in this isolation using photo transformer. So here optocoupler consisting of a pair of infrared LED, as I said. So infrared light emitting diodes and a photo transistors, you can see, observe them in the figure here. So when the input signal is applied to the ILED, okay, the ILED is nothing but infrared LED, so it turns on. Okay, now the light falls on the photo transistor, so photo transistor also starts conducting, as I said. So ILED is nothing but infrared LED. So when the supply is given to ILED, so light it emits the radiations that will falls on the photo transistors, then photo starts conducting. Okay, so there is no electrical connection between the LED and the photo transistor. There is no any connection between the, this is LED and the transistor. Okay, so between them, so the rise or fall time of this photo transistors are very small. So if you give the supply to the LED, then your transistors is acting. If you turn off the supply to LED, your transistors is not operating. So if any fault occurs, you just turn off the LED part, then the faulty section is eliminated, isolated. There is no any electrical connection between the photo transistors and your diode here. So it is a separate and it's a separate. Only the radiations emitted from ILED, that is infrared LED, will be influence the transistor, photo transistor, to starts conduct. So the photo transistor, the function itself is, so whenever there is a light radiations falls on that particular transistor, then only it will be acting. Okay, so that's about photo transistor. The rise and fall time of the photo transistors are very less. Then you can see here there is a MOSFET triggering circuit using the optocoupler. So it's a basic idea about optocoupler isolation. Then we have a MOSFET circuit here. MOSFET we already discussed, metal oxide semiconductor field effect transistors. So how the isolation is happens in this case? So you can see this is a equivalent circuit of the triggering circuit using optocoupler. That is the isolation of triggering circuits using the optocoupler method. Okay. Here figure this one shows the pulses which are given to the input of LED of optocoupler. Okay. So LED, so when the VG, that means gate voltage, is positive, LED turns on. So if the gate voltage is positive, then LED turns on. So now the light falls on the optocoupler. Due to this, T1 turns on. So when the light so so when the wait a minute. So when the supply is given to the optocoupler, so this will emit the radiations. So the light will fall on the, this is the phototransistor internal arrangement. It is completely the phototransistor voltage divider bias network. So when this falls on the phototransistors, so your phototransistors will be starts acting. So if the phototransistor is acting, then the current starts flowing to the gate circuit. So if the gate receives the required amount of the pulses, then your MOSFETs will be turns on. So you have a drain supply and source supply. So if it receives the required amount of gate supply, so then your MOSFET starts conducting. Okay. So how it is receives this one required? So based on the phototransistor emitting the light energy, based on that your transistors is acting, then it will be getting the required amount of this one. So now let this is the explanation. So I have written same here. So when the VG is positive, the LED turn on. Now the light falls on the phototransistors. Okay. Then due to this turn on, T1 is turns on. T1 is nothing but the transistor 1. Just a minute. Okay. T1 is turns on. This is your T1. So T1 is turns on. Okay. So now the gate of the MOSFET is activated. So once the T1 turns on, means the current flows to the gate terminal, it is activated, thus the MOSFET is also turns on. So when VG, that means gate voltage, is 0, the LED is off. If the LED is off, therefore there is no phototransistor action. Okay. Also turns on. So if the LED is off, there is no phototransistor action. If there is no phototransistor action, there is a absence of gate pulse. Okay. So therefore the phototransistor is also turns off. Therefore the no signals appears at the gate of the MOSFET here. So thus MOSFET is turned off. Hence the isolation is provided between the drive or the trigger circuit from the power MOSFETs. So what happens? So if the positive VG, so if the positive supply is given to the your LED, so LED turns on, then your phototransistors acting. So because of the action of the phototransistors, so the gate receives the required amount of the pulse. Okay. So then your gate is conducting, so the current starts flowing to the load. So if the negative VG, so if the this phototransistor supply is given the negative, then the phototransistor is off. There is no emission of the infrared radiations from the phototransistors. If there is no emission of the infrared radiations of the from the phototransistor, then your for ILED, then your phototransistor is also off. If your phototransistor is off, then the gate is not receiving any signal, so then gate is also off. Okay. This is how you can isolate. This is the trigger circuit. Okay. And this is your MOSFET circuit. So you are isolating the MOSFET circuit and the trigger circuit by using the optocoupler here. Opto means light, coupler means coupling, means there is a connection. So optocoupler. So if the light is there, action of MOSFET will happens. If the absence of infrared radiations, the MOSFET is also not operating. So that is how your isolations is takes place in case of these two types. Okay. So in this what we discussed is, so the isolation, how the isolations is need of isolation, why the isolation is required. So need is once again to protect the driver circuits from the faulty currents. So that is why isolation is must needed in all the power electronic devices. Okay. You may get the questions in a different way. So these are some of the sample questions which are asked in the previous year question papers, just listed out based on this particular topic. So there are different, they are asked in the different way, so that is why, so they listed here. So there are, you will definitely get one question from this need of isolations, and explain any one method of isolation, or they may specify the optocoupler method, or they may specify the pulse transformer, but definitely you will get one questions from this isolation, need of isolation, and that technique. Okay, so we discussed why the isolation is required using the some basic circuit. Then we moved to then types of isolations methods. So these for isolations, pulse transformer method and optocoupler methods. So this is your pulse transform method, and we discussed in detail how it is operating. Then we discussed about the um, what is that advantages of this and disadvantages. Then isolation using optocoupler, basic representation. And then we have taken some MOSFET circuits. So we have isolated the MOSFET circuit using the optocoupler method. How the working principle of this will happens if you're using optocoupler to isolate the gate drive circuits of the MOSFET, how it is operated, we discuss. Okay, so that's about the different types of isolations. Okay, next. Okay, so that is about the isolation part. Then we discuss some of the MOSFET advantages and disadvantages of MOSFETs and applications of MOSFET. Then we'll move to the next type of the switch, that is isolated insulated gate bipolar junction transistor, IGBT. Okay, so then disadvantages of this MOSFETs, or merits of demerits of this MOSFET. So MOSFET advantage, it has a very higher handling capabilities, that is power handling capabilities and other things. But so some of the disadvantages is, so it has a on-state losses in the MOSFETs are also very high. Okay, then MOSFETs are used only for the low power applications, so it is not suitable for the high power applications. If you go for, if you want to have high power applications, then you have to go for the IGBTs. Okay, MOSFETs suffer from the static charges. There is some charges will be stored always in the MOSFETs, that is a one of the drawback. Then applications, if you're talking about the applications of MOSFET in low power AC to AC, AC DC drives, it is used. Then in SMPS, switched mode power supplies, it is used. In stepper motor controller, speed control of stepper motor, it is used. Then high frequency and low power inverter, it is used. It is used in the high frequency and low power inverters. Then these are some applications which I have listed. In addition to this, the MOSFET has a variety of applications in the field of power electronics, but some of the just main important applications I listed. If you take any power electronic device or power electronic switch, there is definitely there is a presence of MOSFET is there. Without the MOSFET, there is no power. Without MOSFET, without IGBT, without diode, without SCR, there is no power electronics. Okay, so the power electronics is completely depending upon these power semiconductor devices. Okay, so just to name few, I have listed 5 of the applications. In addition to this, we have a variety of applications. If you go on searching the what are the applications of power electronics MOSFET in power electronics, you will get hundreds and thousands of applications. Okay, so these are some few of the applications on MOSFET. So in the next session we'll discuss about the another type. So till now what we discussed, MOSFET construction, how it is constructed. Okay, then different types of characteristics of MOSFET. Okay, transfer characteristics, switching characteristics of MOSFET, isolation of gate and base drive circuits. Okay, MOSFET gate drive turn on and turn off methods. Okay, then proportional base control methods, various types various concepts we discussed on the MOSFET till today. So in the next session we'll discuss about the another type of power electronic switch, that is high power applications, which is used for the high power application, that is a insulated gate bipolar junction transistor. So we'll discuss the in detail aspects about the insulated gate bipolar junction transistor. What is it IGBT, and how it is constructed. Okay, and what are the different characteristics of this IGBTs, and what are the applications, what are the advantages of this applications, this IGBT and other things we will discuss in the next video. So if you got any doubts here up to here in this particular module, you can ask me at any time. Okay, thank you. Let's meet in the next video. Thank you.